at SKIT Jaipur. I have built a project on e-commerce dynamic pricing and inventory. The core objective was this project to build a modern automated data lake house using a Mendelian architecture. Instead of just analyzing static and the data, I have built a pipeline that processes live incoming e-commerce sales, then cleans the data and calculates the dynamic pricing based on the current stock levels and automatically updates a business dashboard, which you can see here. This is my GitHub account, and you can see here this is the link for this. I have pushed my every file of this project here. As you can see, the bronze file, silver file, gold layer, which is Mendelian architecture, and the incremental, which I will talk later in a few minutes. And because I don't have a real live website to connect to, I have built a Python simulator, this auto live store. What it does, it runs in the background on your computer and generate realistic sales data, including intentional errors like bad dates, to test your pipeline. And it converts the data into a highly optimized Parquet files and pushes a new file to the cloud every 60 seconds. And this is the resource group which I have created for this project in the Azure. Here you can see I have used Databricks, Data Factory and storage account. Firstly, we will explore the storage account. Here you can see I have created a raw data container. In this, all the Parquet files are being landed. As you can see, the incremental files are in the Parquet format, .parquet. .parquet means it is the compressed version of the CSV file, or you can say, and it makes data flow much easier. And it is the place where Python simulator drops the new Parquet files. As you can see here, sales increments. And this is the Azure Data Factory. This is the nervous system of my project. What it does, instead of manually running code every time a sales happen, ADF uses an event trigger, which you can see this. So the exact second a new Parquet file lands in the data lake, ADF detects it and automatically triggers the Databricks notebooks to wake up and process the new file. And you can see that I have created a Databricks notebook where I can drag this to this, and I have linked the Databricks linked services setting and destination, and I have given a notebook path to the incremental load, which will increment the data, or we can say append and merge. This is the Azure Databricks, which we have launched from the Microsoft Azure. You can see this is my cluster of active memory 16 GB in this. These are the default values. Moving on to the workspace, there are only 4 files: the bronze layer, the silver layer, gold layer, and incremental load. The only job of bronze layer is to ingest the raw Parquet files from the data lake and save them as Databricks delta tables. In the silver layer, you will find the cleaned and enriched data. All the filtration, cleaning are done by the silver layer. In this, it calculates the dynamic pricing also. If the inventory stock level is dangerously low, it increases the product price by 20%, and if there is too much stock, it drops the price by 10%. And the gold layer, it takes the massive detailed silver tables and aggregates them into small fast summary tables: gold sales, gold underscore sales underscore daily, and gold underscore inventory underscore risk. And this is the Power BI page. Instead of copying the data, the Power BI connects to the Databricks using a data query. This means every time when we click the refresh, the Power BI adds the Databricks goal table for the suitable newest number guaranteeing the dashboard is always displaying live and automated data.